Good afternoon. Thank you for the opportunity to participate in this conference. I am Máté Józsa, PhD student from Babes-Bolyai University, and my talk is about the estimation of Gini coefficient from incomplete datasets. But first of all, what do we mean by incomplete datasets? Let me start by introducing the types of data we can come across during analysis of income or wealth. If we have luck, we can have access to the incomes or wealth of each individual inside a geographic area. But as you may suppose, this is seldomly the case. On the other hand, in most of the cases, we can have access to statistics on some regional level, for example, the number of individuals inside a settlement or sub-region and their total income or wealth. Now, to characterize the level of inequalities inside a region, the most convenient is to use the Gini coefficient. This is a number between 0 and 1. 0 represents the most equal society, where every person has the same income or wealth, while 1 represents the most unequal society, where a single person has all of the income or wealth and others receive nothing. As we can see, Gini coefficient should be defined for individual level data. So we need access to the individual incomes or wealth or to their distribution. If we replace these with the statistical counterparts, the average income, we course grain a considerable part of inequalities. To overcome this issue, we propose a novel methodology to work with such type of data. As I mentioned, to calculate the Gini coefficient, we need the distribution of incomes or wealth. Because we have access to only the mean incomes inside the geographic areas, it is convenient to assume exponential distribution inside those. Naturally, a better approach would be Pareto distributions, but their two parameters cannot be determined solely by the knowledge of the average. Also, in most of the cases, exponential fits very well the data, as we can see here in the case of a small commune near Cluj in Romania. Accepting this working hypothesis, we unite the presumed exponential distributions to achieve the complete distribution inside the considered area. Considering this into the definition of Gini coefficient, we get a compact result for the total Gini coefficient, as you can see here. To prove our hypothesis, we had a closer look at the individual level data from Cluj County in Romania. Here, Cluj County is considered as the studied geographic area. The nice about this data is that we have access to the incomes of all individuals in the county. The blue crosses show the distribution of those. On the other hand, we know also the mean incomes of all settlements inside this county, and we can build a distribution of incomes on county level using our proposed model. This distribution is represented on the figure with orange crosses. The probability distribution derived from the two methods coincide nicely, leading to a very similar Gini index. It is interesting to note that they both follow the same Pareto distribution. The good news is that the traditionally calculated weighted Gini coefficient also coincides with this. We can add a little more complexity to the problem by introducing along with the total Gini coefficient two more relevant measures. These are the internal and cross Gini coefficients. The internal Gini coefficient characterizes the differences inside the settlements, while the cross Gini will characterize the differences between individuals in different settlements. It is easy to realize that these two measures can be computed as indicated on this slide. As one can notice, the cross Gini coefficient closely resembles the previously introduced total Gini. We just have here less elements in the sums and in the average. Our data suggests that the value of the total Gini is very close to the cross Gini index. We plot here the difference between the total and cross Gini coefficient in the case of all settlements and communes in Romania. Turning back to the data, we calculated the discussed measures on the data available on Romanian settlement, commune, and cities. We had access to settlement level data for 18 consecutive years. These are all statistical data, not individual level. So we applied our method here. Here we represent the time-like variation of the cross and internal Gini for Romania using the statistical data on different levels. We noticed that using settlement level data, blue curves, the internal differences are higher than cross differences. While using the data on commune level, the green curves, the effect is inverse. Understanding this result is a work in progress in collaboration with social scientists. It is also interesting to note the obvious drop of internal social inequalities on settlement level in time. All the curves converge to a value around 0.5, which is characteristic to a pure exponential distribution. Let us summarize now our findings. First, using statistical level data, we estimate the individual level income or wealth distribution inside a geographic area. We assume exponential distribution in each settlement, as this has one free parameter which can be estimated from the average. By uniting these distributions, we achieve the characteristic distribution for the considered geographic area. And the data from Cluj-Canty confirm the validity of our hypothesis. Internal and cross Gini coefficients were introduced and computed with the proposed method. The internal index characterizes the differences inside the settlements, while the cross index the differences between individuals from different settlements. We noticed that total and cross Gini formulas are very similar, and their experimental values also coincide. Calculating these measures for Romania using data on commune and settlement level allowed us to follow the time-like variation of these quantities. The obtained results will be interpreted in social context in the future. Thank you for your attention.